Hello, everyone. I'm just here to talk a little bit about the idea of what electricity is and why that's important and things. With all of the stuff going on and the distance learning that we're going about and having to do, um, we are going to be cutting the physical computing aspect of this course. Um, so basically, I'm just going to talk a little bit about what electricity is. And this is going to kind of lead into some of the circuit building that we were going to do, but now we can't because of time. So this is kind of an optional thing to look into if it seems kind of interesting. So I'm going to talk about the basics of what electricity is, how we use it, um, things of that nature. Okay. All right. So I'm going to share my screen. All right. There we are. So you should now be seeing um, this screen here. Um, and this is a little PowerPoint that's put together. I'll have a link to that in the description of this video. Um, so whenever we're going to do this physical computing section, there were kind of three main parts. There were parts utilizing electronics, utilizing microcontrollers, and then utilizing networks. Networks we weren't going to do too much with. That's essentially just combining the various microcontrollers and electronics via the internet or some other way just to make different ones communicate to each other. Um, for the most part, we're just going to connect things via USB to our computer and have the two different programs talk to each other. So working our way back from right to left, that microcontroller and code, that was essentially what we were going to do is have a circuit board, one very similar, not the exact same one as what's shown on the screen there, that we would then use to connect uh, to our computers. It would run a specific set of code that we would have programmed it to do, and then that would tell it how to output and input different electrical signals to different circuits. Working our way back to that electronics section, um, there's a few diagrams there. One is a basic circuit diagram, um, basically showing some different ways to connect different things like resistors, capacitors. There's a switch in there, I believe. Um, or no, it's just an input. Um, but anyway, we would have been building circuits with wires for this electricity to go through. And then that's just showing on the far side here, we have a battery that's hooked up to a light source. And so the electricity is traveling from the battery to the light source back, and it's showing kind of the cyclical current of electricity moving back and forth and back and forth. Some of the things we would have used with the electronics, so actuators, so kind of like a motor. It's taking electricity to move something. Resistors, which I'll talk about in a little while. Transistors, capacitors, just different combinations of things, different power sources, outlets, batteries, things like that. Uh, would have used some of that stuff, but that's a little irrelevant. So the main point of this is, what is electricity? So inside of every atom in existence, for the most part, um, are tiny little particles called electrons. If you've taken a chemistry class or maybe some parts of a biology, uh, maybe a physics class, it's been a little while, but definitely a chemistry class, you'll talk about all of these things inside of atoms. They're mainly composed of protons, neutrons, and electrons. Electrons are the kind of smallest particles that make up um, an atom. Um, and they move, and essentially they kind of orbit around the nucleus of the atom, which is composed of the other two parts. Now, all not all atoms can have this happen, but when the electrons kind of move from A to B, um, that's essentially what electricity is. It's just electrons moving from one point to another point, um, and that's really it. Um, so not everything can have this happen, though. Insulating things with insulative properties don't allow this electricity to pass through. So, you know, rubber is a kind of a big one that comes to mind. The coatings on bigger wires. These kind of things do not let the electricity move back and forth through them, and these are kind of what's known as insulators. Now, other things such as wires, metal, solder, things of that nature are called conductors because they do allow this electrical current from the electrons to move from A to B to C and so on. One thing I want to point out just as a reminder, electrons have a naturally negative charge to them, the opposite of protons, which are positive. So when these electrons move from A to B to C, kind of down the line, this causes an influx of this negative electrical charge to combine in one spot. So when there's a lot of negative charge, there's also a lot of positive charge because there's a lack of electrons in the previous area. So we're moving down the line, and this electrical charge is flowing down the wire. So that's essentially what is important there. So let's see. There are three important aspects that come to play in every circuit. That's the voltage, the current, and the resistance. I'll get into each of that in just a little bit. But those are just kind of different aspects of how electricity flows. So whenever we utilize electricity, we're sticking it in a repeated loop, and that repeated flow of electricity back and back again is what is used to power our various electronic devices. So I just want to kind of describe some of this stuff here. I've got a diagram on the screen now. So say you had a water tank, which we kind of have described here, with a water pump. That'll be our power source that is pumping through the water, pumping the water through the tank in a continual cycle, like so. All right, so essentially the amount of water that is moving through this system, that is the current, like as if our electricity, if the water was the electricity, it would be the current of it is the amount of water flowing through the pipes. All right, so the pressure of the water, essentially that is the voltage of it. That's how fast the water is moving through these pipes, equating it to that. And then kind of a way to think about maybe the thickness of the pipe, if there was a filter or something blocking, any way to impede that flow of water or really electricity is equated to the resistance of that. So by increasing the resistance, you decrease the amount flowing, you would increase the voltage. We'll talk a little bit about that in a second. There's an equation that's good for learning stuff, but we'll talk about each of these in just a little bit more detail before we get into Ohm's law. So voltage is a force that pushes the current through the circuit. You know, kind of like this diagram, we kind of keep with that water metaphor. Instead of a pump, though, you can see it's a waterfall going off. So the gravity that is pulling the water down through the waterfall, that would be considered the voltage of this system if it was electricity. So this can be kind of described as the energy between 2 points. You know, it wants to move from A to B, where there's more to less to kind of even that out. But since it's a cyclical thing, when it moves from more to less, now where there was more is less, so it goes and it moves in a continuous circle. That's why when we start building circuits, you'll notice that it won't really work until you build that complete unit. All right. So, and then voltage is just measured in volts, or V. You'll see that abbreviated. Currents, just in a little more detail, that is how much information is inside of each, sorry, not how much information, how much just stuff is in the system. Keeping it up with water, if you had a water hose and turned that on just a little bit, you'd have just a little bit of water current going through, but as you increase it, you would get more and more flowing through the same section. The current would increase. So kind of like a river, it's got the current, you're flowing down it. It's that kind of idea, just with electrons and not with water. Um, they're measured in amperes, which is just kind of shortened to amps anywhere you see it, or a lot of the time. And then lastly, resistance, keeping with um, the metaphor of rivers and waters. Um, if you had a bunch of rocks in your rivers, that would slow down how fast the water can get from A to B. Um, excuse me. Quiet. Um, move from A to B. So as that goes along, the more resistance you have, the slower the current. Um, and so on. So that would essentially slow down the electricity to be within a certain range. We can call it the load, if you'll sometimes see it referred to as that, and that's just talked about in ohms. Uh, the last thing to kind of talk about are the power sources, or where this electricity is coming from. So things like batteries, they'll store the kind of the chemical energy that's used to excite the electrons um, in the system, cause them to move in the circuit. Um, you'll get electrical current from different kinds of outlets, like in the wall, and things like that. So there's just some little descriptors here of what these power sources kind of do. They, they essentially energize the electrons and create this voltage, this electrical pressure, which then kind of powers the whole thing. It causes the current to flow. Um, and then we'll kind of get on that. And then anything in the system that impedes that at all is the resistance that I talked about. So I mentioned before Ohm's law, and Ohm's law is kind of important for figuring out really most everything for this class that you would need to know with electricity. And that is kind of the relationship between the voltage, the current, and the resistance. Um, so this thing is the current is equal to the voltage divided by the amount of resistance. Or you could flip that around and say that the voltage is equal to you can essentially it's just an inverse operation. So um, if I were to divide both of them by V, you'd get the resistance is equal to the current divided by the voltage. If I were to multiply both sides by R, we'd get the voltage is equal to the current times the resistance. Things like that. It's just this inverse relationship between all three of these items right here. Um, and we can use that to say, oh, if I have 5 volts of electricity and um, I stick on a 100 ohm resistor, how much current is moving through the circuit, that kind of thing. Or if you have a specific element that needs a specific amount of resistance, how much current do you need to power it, and so on and so on. So it can be useful. Some other things with powers, kind of the combination of the current and the voltage. That's if you've heard the term watts before, like a 60-watt light bulb. That's kind of how much power you need for something. It's just a volt times the amps. So these circuits, as I mentioned, these things happen in a cycle, going around and around and around and around. There. So this diagram that we had from the first slide here, we have the battery with the electrical current moving. It goes into the lamp, powers the lamp, which it has a little bit of a resistance built in, and then goes back to it. Electrons naturally flow from the high energy side to the low energy side, which is also called ground. Let's see. So you'll notice that kind of diagram is kind of illustrated right here. You got the plus side moving around, indicated with the arrow there. So just about everything has some little resistance um, built into it. Wires have resistance to it, very low resistance. Air has resistance. You have resistance. Every little thing has some element of resistance. We can add more to it by having what's called a resistor, just by flowing the electricity through a physical unit that you wire in that just has a specific amount of resistance already, so you can program all of your electronics correctly. If you ever have anything where there's no resistance at all, your electricity will just flow through it almost instantly, and that's what's essentially called a short circuit, if you've ever heard that before. That will pretty much break your electronics. Um, all right. And like I said, the conductors, usually wires, are what's used to move these electrons through these circuit components. Because while they do have resistance, they're extremely low. So the electricity just naturally wants to move through them uh, because it's easier for them to. If you have kind of the metaphor of the rocks in the river, the water wants to move where the rocks are not, kind of flow where there's less resistance. So would this work? What do you think? We'd have just a D battery hooked up to a uh, light bulb. Based on what I've talked about so far, we will. Would that work? Okay, they aren't going to show me the details of it. Um, so looking at this one, it would not work because it's just a wire connected from the positive end of the battery to the light bulb. This would not work because, as I mentioned, this electricity, in order to utilize it, it's a cycle of electrical current moving positive to negative through all of these elements here. So since it's connected to the light bulb but not back in a circle, it will not work. You will not power the light bulb. Looking at the next one, um, we have kind of a circuit. We have the wire connected to the battery, to the light, back to the battery. However, you'll notice they're both going to the positive end of the battery. This is not going to work. You're going to cause a short circuit because essentially the electricity won't be able to flow in the proper directions. I guess maybe not a short circuit, but it won't work because all of your high energy electrons are going to be kind of in the same place. They won't have a place to go for the low energy, which will be that bottom end of the battery, which is what we have right here. So you'll have the battery, which is connected to the end of the light, which is then connected by a wire to the negative end of the battery. So our electrons can move kind of in this cyclical pattern of going, from the bottom of the battery up to the light, back down to the wire, up to the light, back down to the wire, over and over again in order to power our little light. And this is just kind of showing that in detail. We have that closed circuit, which is kind of an element that we'll be, or would be talking about in electronics. Essentially, we would have whatever we wanted to power hooked up to the, the positive and the negative ends of our circuit with whatever resistance we needed in there as well. So there are different things. I mentioned resistors. Again, those are things you can put into the circuit in order to give a specific amount of resistance to your circuit so that everything works properly. You don't overload something with too much power. With their switches work, they either connect or disconnect the circuit, so you can essentially turn things on or off with switches. Diodes and LEDs are lights, and then capacitors, inductors, chips. We don't need to go too much into those. Those are just different parts of electricity. Capacitors can store up some electricity. The chips it talks about is like circuit boards, things like that, where you can essentially solder all these connections together so you have them all ready to go. Here's some pictures of resistors. What's called a fixed resistor is what I've talked about so far with a specific amount, and they're kind of talked about with the and differentiated by the colors and the stripes on them. And that there, what's called a variable resistor over here, kind of like a dial, is where you can plug it in and you can essentially turn or slide it. And by the position of these, it changes the resistance so it can max to what you want. And that's just if you need something that can change in its resistance. These are some of the diagrams used to represent them in electrical diagrams. We'll get into more of that later. As I mentioned, the resistors are differentiated by the color bands on them. This is just a diagram for kind of telling them apart. So what they're ready for is kind of the maximum wattage by the size. Again, our small ones are rated for 1/4 watt, so not a ton, but you can still use them for most basic things. Um, so here's some examples. I'm not going to get too much into that, um, but there's all of that there. You can pause the video and check out the diagram if you want. Uh, and then I'm not going to spend a lot of time with this because this is an ungraded assignment, but we've got a resistor here with these 3 bands. We don't really need to know about that 4th one, but going back to that, we got a pink, pink, brown. So pink, pink, brown. So 330 ohms is what that one should have been, plus or minus 1%. Basically, that's just the variance in it, how accurate it is. So pink, pink, brown, or I guess orange, I should say. It's just the color in this video is a little weird. Or was it orange? Yeah, that was the orange one. 33 times the brown, which is times 10, so we have these two and then a multiplier. So 33 times 10 is 330 ohms. Ooh, all right. I've talked about switches a little bit, and they essentially pass or interrupt the flow of electricity. Um, a switch is essentially also a button. Essentially, there are 2 contacts inside of it, and you either connect them or don't. Here are some toggle switches where you slide them back and forth, and as long as it's in the on position, it'll pass the current, and then if it's in the off, it won't. And then there's a button here, what's called a momentary switch, and it will only, most of them will only pass the current when you press them. Using electrical diagrams, you can kind of see that labeled out here. We have it not connected, and when you press the switch, this would move down and connect, and our electrical circuit could pass through. There's also what's called a tilt switch. So you have your signal coming in and then going out. It goes in A, comes out B. As you tilt it, this metallic ball connects to both of them, and the electrical current, because metal is a good conductor, will pass it through the ball, through A to the ball, out B. So it'll only happen once you've tilted it so that you can connect things. That's a good way of making some interactive items. To a degree, unless you have digital ones, that's kind of how some old school tilt sensors and gyroscopic type things would work. Diodes and LED. These are essentially lights. So they allow electricity to flow through in one direction and not the other. So you'll notice that you have, if you plug these in backwards, it won't work. And if you aren't careful, that could short them out. You'll notice that one side is longer than the other on the wires, kind of detailed a little bit in this diagram right there. And that longer side is the positive side. So the first side when you're plugging it in. So that's just how you can tell that apart when you plug them in. All right. They use very little current, as you can see here. So you'll need some kind of resistor in order to get them to work, so that way you don't blow them out. Essentially, yeah, it's just a light emitting diode. So electricity flows through in one way and it emits light. You can have different filters on it to create different light, things like that. And there's a few pictures of them here. They have all kinds of different styles. Other components, as I talked about a little bit, capacitors, they store electricity kind of like a water tank, and they can just release it at later points. Let's see, transistors and relays are kind of switching devices. Let's see, so pretty much they can be thrown by your finger, but they can also be controlled by the microcontroller themselves. So there were some switches in the Arduino. Again, we won't really get into that much of it. Some of these symbols for the, if you were to look at some of these diagrams, you can see resistors, variable resistors, different kinds of switches, just different kinds of symbols. Again, we won't get too much into this, but if you're ever looking at circuits, it can be useful to kind of get through and kind of understand exactly what's going on just from a basic diagram. So you can kind of check those out if you want. Um, and then naming convention, you have R for resistor, C for capacitor, inductor, switches, and so on and so on. Just so that way you can, if you see just a letter, you know what each thing is. Here's a basic diagram so you can kind of see we have the battery with the positive end. It's 3 volts going through a 220 ohm resistor to a red LED, which we got showing that there. So that's a pretty basic one. Not all of them will have the information like it's a red one or some of this number there, but it's helpful to have. Simple circuits. There's a little diagram here. We got when you wire things together, you can wire them in a row, so that way there's one path for the electricity to go through. So a lot of old Christmas lights were done like this, just in a series. So if one light in the entire strand went out, they would all go out. So you'd have to test every light bulb. It's a pain in the ass. Parallel circuits are a little bit better. Essentially, you can kind of see the difference in there, and that essentially allows the circuits to travel through each light independently. So if one goes out, the others can stay on. Because if this, say this first one goes out, the electrical signal is still going past it to the next one and back, and then past that one to the third one and all the way back to the battery. Whereas in the series circuit, it was moving through this one to the next one to the next one before it got back to the battery. So that's essentially how that works. So when you're wiring in multiple things, that's just something to think about. All right, and then here's a diagram of that. Again, I'm not going to go into too much detail because we won't actually be going over this in class. It's just some basic things about electricity that's important to know. If you want to check out more, I'll have the slides in the description, or you can ask me and send me a message. Here's a parallel circuit, so you can kind of see how we have this resistor and this resistor, and they're parallel to each other. All right, we don't need to go into formulas for this class, for this part, but they're there if you want to look at them and are interested. And then some examples, some questions, you can figure some stuff out, and all of that. Okay, this is the last little section I think I'm going to talk about in this video, and that is the idea of a breadboard. This is what you would use to build these circuits together. So you would have the, in this one we have a power source, which you would normally get from our Arduino chip. Gets plugged in. And the way this works is you have these rows, you notice they're labeled positive and negative. Underneath them is kind of this metal strip, and then in each little hole is a tiny little clip. So you would plug your little jumper cable into that, this tiny little wire, and then you can connect that to some other point on the board. So say you had your signal coming in to this positive row, you can then connect it from the positive row to, say, 7C, and then everything in that horizontal row in the middle is connected. So anything in 7, you get A, B, C, D, and E that you can then connect to whatever else you want on the board. You'll notice in that second diagram, you can see there's the horizontal versus the vertical. It's just the underside of it. And again, each little hole has a little clip in it, and then they're all connected via this metal. And you can kind of see that outlined in the third diagram with these little green lines. And then there's this third one here where you can see there's an LED. We got the resistor going to the LED, which is then going back to the negative, and then all that's connected to this battery. We got the potentiometer that's plugged in, some switches, a little motor, all wired in that same way, connecting them that way. All right, so the wires here. Wires are what I mentioned, the kind of jumper cables, short wires used for connecting all this stuff. Traditionally, wires are used for the positive connections, things coming from the battery. Usually black, sometimes green, but mostly black, are used to connect to the negative, to the ground, after everything. And then all the other colors can be used for whatever you need to connect all the components. Um, so yeah, that's not a hard rule. I mean, physically, a green wire is identical in this set to an orange wire or a blue wire. Um, they just have different colors, so that way you can tell what's what. So almost always, I'll put the red wire for the positive, and I'll do black whenever I can and go from there. This is an example of that. You've got the red wires with the positive, the black wires with the negative. In a breadboard, you'll notice there's this divide down the middle. So the left side is separate from the right side. So you'll have to connect them with these jumper cables in order to get power to both sides. All right. And here's just a circuit diagram showing that. So here's the circuit diagram, and then here's how it's wired. So I've got the battery source. The positive goes to a resistor. So the positive is connected here via red wire to the resistor, which is then going to a switch, which if you follow that down, the resistor goes to this row. We've got the switch, which is then connected to the LED whenever it's on, LED. So we get that to wire LED to the positive, goes through, which then connects to the negative via the black wire, which, as you'll see here, positive, resistor, switch, nothing's connected to that third pin, nothing's connected to the third pin. So it's either connected or not, to the LED, nothing happens, which then works its way straight back to ground. So you can kind of compare A to B. These are the exact same thing. All right, here's some example wiring bits. I'm not going to go into too much detail, again, because this is just a general for your information kind of walkthrough of these things. We won't go into these lab problems, but you can check out the slides, which I will post. So there's all of that. If you have any questions, again, shoot me a message. That was a big information dump kind of all at once. Again, just talking about kind of the concepts of electricity, how circuits are built, why you might need to put resistance on stuff, the idea of different sensors. I should mention this because it's on the screen here. Some of these potentiometers and things are what's called an analog sensor. So it's a consistent change of things. It's the signals being changed continually versus a digital sensor, which is just using the prefix die for 2. It's either on or off, digital on, off, 1, 0, that kind of thing, versus the analog where you can kind of get discrete values in between them. So that's that. Yeah, so this is just something you can check out if you want. It's a good resource. As I mentioned, unfortunately, we won't get into this part of the course, but I just want to kind of go through it because in a few of my previous videos, I mentioned the idea of electricity and electrical circuits, particularly with microphones. And this is just kind of the basis of what's happening underneath all of that. So yeah, again, this is a big data dump. If you have any questions, shoot me a message. I'll answer them. Have a nice day.